Okay, we got some integrals involving the exponential function base e. Two rules in this section, two new rules. First of all, the basic one, the integral of e to the power x with respect to x is e to the power x plus c. Okay. Again, one rule you probably won't use too much because it really only applies to one function, just e to the power x integrated with respect to x. But the second rule is the one you'll probably use in a lot more of the problems. Basically, if you look at the very far left here, it's really telling us, under what circumstances we can integrate e to a more complicated power, u. Okay, so suppose you have an integral with respect to x, but it involves e to some big power, not just x, but some complicated function. Well, if you can make this substitution, you can integrate using this rule. So essentially what we need to have is the integral of e to a power times the derivative of the power with respect to x dx. And under that circumstance, what we really are just integrating is e to the u du, which is e to the u plus c. Okay, so let's try it out on this one. Okay, now first of all, I've got an integral here, a lot of complicated stuff, but I do have that 5 sitting in the very first part of the integrand, so I can factor that out and write this as the integral of x squared e to the x cubed dx. Okay, so we look at this function inside the integral sign and we say, well, it's a little complicated, so probably we need to try one of these substitutions. And again, whenever you have e to a power inside the integral sign in the integrand, you probably want to call the power u. So we'll let u be x cubed. Okay, so we're going to replace that x cubed with u, but we also need to replace everything else. So to do that, we need to find this thing du. Okay, and remember, du is just the derivative of u with respect to x times dx. So the derivative of u with respect to x is 3x squared. Okay, just taking the derivative of x cubed. Okay, so du is that times dx. Okay, so let's see what we can do here. Okay, so let's continue the process. Okay, we've got 5 times the integral of e to the x cubed, okay, times x squared, leave myself a little space here, times dx. Okay, well, if you see here what we can do, we can certainly replace that x cubed with u. So we could write this as 5 times the integral of e to the power u. Okay, but if you look at the formula here, we need to be integrating e to the power u du. Okay, well, and this is what we have left, x squared dx. Okay, but du turned out to be 3x squared dx. Okay, well, not a problem. We just have to multiply by 3, which we can do as long as we multiply by a third right next to that. Okay, and this is a trick we used in the last section on the generalized power rule. So we want this du to be something we can replace in the integral sign, but we're not quite there. We've got just x squared. Well, we can multiply by 3 as long as we divide by 1/3. Okay, so here's what we're going to do. We're going to go ahead and factor out that 1/3. Okay, that'll make it 5/3. And then the only thing we have left here is just e to the u times du. Okay, so we had to, kind of, mess around with the constants a little bit, but in the end what we get is 5/3 times the integral of e to the power u du, and the rule tells us that's e to the power u plus c. Okay, so finally we replace e to the power u with, we replace u with what u is, and u is x cubed. Right, remember, u is just our little temporary substitution. We need to go back to the original problem, which phrased everything in terms of just x. Okay, so making that substitution worked, and we got the indefinite integral. Okay, there we go. Okay, well, just want to do another one, kind of a similar one here. You can probably go ahead and see right away, we could factor out that 5 if we want, and get e to the power 2 minus x dx. Well, it's maybe even a little simpler of a power, but the power is 2 minus x. Okay, if it was just x, we would just use this first rule we have. Okay, but the power is something else. The power of e is 2 minus x. So we have to call u 2 minus x. Okay, and du, remember, that's the derivative of u with respect to x. That'll be a minus 1, okay, times dx. Okay, So actually this one wasn't maybe even quite as bad. Now if we make this replacement, we get 5 times the integral of e to the power u. Okay. Okay, but look, we just have a dx here. Okay, so what do we do with that? Well, we need to have a minus dx in order to call that du. So again, we can do our trick. We'll multiply by a -1, okay, which is okay as long as we multiply by a -1 right next to it. Okay, those negatives will cancel if we want to multiply them back together. But instead of multiplying them together, we kind of keep this -1 separate, and we can factor it out. So we'll get -5 times the integral of e to the u, and look what's left here. That's just du. Okay. So this one really was the exact same rule, just a different substitution. We get -5 times the integral, which is e to the u plus c. Okay, and remember, this this -5 doesn't have to distribute into the constant because it's an unknown constant. If we multiply by -5, it's still an unknown constant. So yeah, that's all there is to it. -5 e to the power 2 minus x plus c. Okay, and again, like all of the integrals you've done in this chapter, if you're ever uncertain about your answer, you can go ahead and check it just by computing the derivative of the indefinite integral. Okay, if we compute the derivative of this function, we should wind up with, the thing we started with, 5 times e to the power 2 minus x.